Let's get started. I'm a PhD student at University of Exeter in the UK. I'll show you how to use WASM or WebAssembly on embedded systems that use real-time operating systems. Maybe it's more intuitive to show you a quick demo. So here we have the same WASM game running on different platforms. On the left side, we have the WASM game running in the browser using JavaScript. And this one uses Pygame using Python. On the right side, we have ARM Linux that uses HDMI cable as the output. We can also use an LCD as the screen. And the last one, an even smaller device, ESP-32, that uses Arduino. As you can see here, we can run the same WASM game on different platforms. But how? A brief introduction to WebAssembly or WASM. WebAssembly was designed for browsers. Before we have WebAssembly, web browsers can only recognize JavaScript code. But some most popular libraries were written, such as OpenCV. They were written in C or C++ code. We can't just use OpenCV in the browser. So to solve this problem, we can first compile the C or C++ libraries to WASM code. And the browser provides a WASM runtime so that we can use the C or C++ libraries in the browsers. But how about embedded systems? For embedded systems, we have very limited resources. Say, for example, for a laptop, it is very common to have 16 gigabytes of memory. But what if we only have 64 megabytes of memory rather than gigabytes? And we have a slower ARM CPU. And in this case, we need a different WASM runtime that runs on ARM Linux. Say, for example, the wasm-3. So in this case, we can deploy the same application on ARM Linux. But the problem is that ARM Linux, it is still Linux. What if we have only 600 kilobytes of memory rather than megabytes? And we have a much slower, a way more slower CPU. It runs on 120 megahertz rather than gigahertz. And in this case, we have the wasm-micro-runtime that runs on real-time operating systems, such as RTOS, Zephyr, free RTOS, etc. So in this case, in this demo application, I used RTOS, an open-source real-time operating system. And the last one, we can also use wasm-3 runtime on Arduino. And this is an even smaller device. So this is how we use WASM on different platforms. Basically, we use different runtime for different hardware. If we look at the WASM code, actually, it only does some calculation and saves the data to the memory. If we display the memory on the screen, we have the graphic user interface. But for embedded systems, it is more important to have access to the hardware, such as file system, sockets, GPIO, I2C, and SPI bus. Because for embedded systems, we need access to the hardware. To solve this problem, we have WebAssembly System Interface, or WASI, so that we can access the hardware. Another benefit of using WASM is that it supports different programming languages, such as C, C++, Golang, and Rust. So we can use different programming languages to develop WASM code or WASM application. Here's a summary of the hardware, runtime, and programming languages I used in this project. If you are interested in this project, you can find the source code on GitHub. And if you scan the QR code, you will find access to the talk slides. Thank you. This is the end of my presentation.